talk about operators. In Swift, the operators are not that different than the operators that are present in other programming languages like C, C++, Java. And if you're coming from the background in those programming languages, things should just flow for you. There are few things that you need to note, like the increment operator and the decrement operators, which are very common in all the three languages, are not present in Swift. You have to use assignment operators to do similar job. And I will cover those nuances as I go over the different operators. But for most part, Swift operators are very similar to the operators found in other programming languages. We start with our basic arithmetic operators, and I'm going to be showcasing a slide on each types of operator just in case you want to keep it for reference. I have a playground which is ready. I have two variables which are defined. One is x, other is y. And since I'm not going to be changing the value of these variables, I'm going to change them to let to make them constants. And for arithmetic operations, we can simply start with the print statement. We can say is sum of two numbers. And as we covered in a section for string interpolation, you can write expressions inside the strings directly by using the backslash, starting bracket, and ending bracket. So 10, I'm just going to say x plus y, and that should be 12. Okay. And you see, okay, it is 12. And then I can say is subtraction is going to be, as you guessed, x minus y. You have multiplication, which is going to be x into y. And you have division, which is going to be x divided by y. So all good and dandy till this point in time. As you can see, okay, fine, some subtraction, everything makes sense. Yes, we do have modulus or the remainder operator. So you can use that one as well. And you can simply say is x percentage y. And that will give you the fact that, okay, 2 is divisible by 10 and there is no remainder which is left. All good and dandy. Now, let's change the numbers a bit. Let's say instead of 10 and 2, y was 3. And I will go over why I'm doing so. Let's look at the answer now. Well, sum, division, sum, subtraction, multiplication, all make sense. Division, not so much. Well, we start looking at 10 divided by 3, and the answer is 3. And for those eagle-eyed people, you'll be like, okay, that's not the right number. It should be 3.33. So why is it showing as 3? Now, remainder is correct because 3 into 3 is 9, and we are left with one remainder. So that's good. Now, Swift is all about clarity, which means that Swift wants you to explicitly declare what you're trying to do with the variables. Since the data type, which is inferred by Swift for x and y, is going to be integer, and I'm just going to print it up for us so that we know that Swift is treating it as in data type. Okay, so it's in type. Swift is not going to convert integers to floating point or doubles on its own because for Swift, you intended to divide two integers and you're going to get an integer back. And of course, the division of 10 divided by 3 was 3.33, but the integer value of it was 3. And as a result, you see the answer 3. Now, if you really want a decimal point or floating point value to be returned, like the exact division value of this number, let's say I'm just gonna print a separate row for it, okay, saying exact division value. And let us say that you really wanted x divided y to give you 3.333333 and so on. You need to tell that to Swift, which means is that you need to convert these numbers like x and y to doubles explicitly. Now you're getting this error and did that intentionally because it's saying that, well, I cannot convert value of type into expected argument double here. Uh, and it looks like the error occurred because there is no such function as double of x, and that's not the case. The case is that now you are trying to divide double with the integer, and for Swift, it doesn't make any sense. Swift is saying that, well, either you're trying to divide integers with integers or doubles with doubles, but how can you divide double with an integer? So it's not going to auto convert y to a double for you. And that's one difference as compared to other programming languages. In other programming languages, if you have a background in those, if you convert one part to double or higher precision, then the second part is automatically assumed to be of higher precision. But that's not the case with Swift. In Swift, you have to be explicit. So we had to explicitly go and say that both sides of the division are basically doubles, and then you get your double decimal point floating value for the same. Now you may be wondering, why am I seeing 3.33333 instead of 0.25 like 3.33? And yes, that is doable using the string interpolation operators, but that's doable using an extension, which is available in UIKit. So you will have to import the UIKit framework at the top. For now, don't worry about it. When we talk about extensions, I will cover it. That cover our basics for arithmetic operators. And like I said, it's going to be pretty straightforward. Now let's look at comparison operators. Now, if you're coming back again from language background in C, C++, and Java, very familiar, nothing out of the box. These are comparison operators trying to assert in case one value is bigger than the other, equal to another, or any combinations of those. The operators which are available are double equal to, which is x and y both are equal, not equal to, both are not equal, greater than, one is greater than other, less than, one is less than other, greater than equal to. And so it takes care of the fact that, okay, if you're comparing 5 to 5 and then you're using greater than equal to, that also actually computes to true, and less than equal to. Let's look at some examples of comparison operators. Again, I have my happy variables defined, x and y. I'm going to convert them to constants to emphasize the fact that we should declare constants unless we intend to change x and y in the code somewhere. Now let's see what happens. Okay, and we're going to simply say, is x equal to y? And the answer is going to be, as you might have guessed, false. X is not going to be equal to y. Now we can do the same exercise for a bunch of other operators. X not equal to y. X is greater than y. X is less than y. X is greater than equal to y. X is less than equal to y. So a bunch of checks which we have done to make sure that things actually make sense. And okay, so I think here's what has happened, because I just put it after x, is actually considering this as the unary operator to force unwrap. Now we'll talk about this a bit later, but for now I'm just going to put a space. When we talk, when you listen to the video on Swift optionals, you will see what Swift unwrapping is. And if you put an exclamation sign after an optional, you're trying to force unwrap it. Since I forgot to add the space after x, Swift assumed that I'm trying to unwrap an optional, but x is not an optional, x is integer type, and that's why it was complaining. So all errors have been resolved now. Now you can see is that, well, x is not equal to y, true, x is greater than y, true, x is less than y is false, x greater than equal to y is true, and x less than y equal to false. Now let's make both of them equal and run this code again. Some variations you will observe is that the greater than equal to operators now start returning true. Same is true for the less than equal to operators. That's all you need to know about comparison operators. You will use the comparison operators heavily when you come to conditional statements. And in the conditional statement, you are looping through sometimes X number of times. Sometimes you are just doing condition checks for if else. That's where the comparison operators will come handy. Next, we'll move on to the logical operators. Now, these operators are something that you will use again heavily in the if conditions, primarily because there's rarely a scenario where you are doing a simple if check, that if x is greater than y, do something. A number of times you have 2 or 3 checks that are together, which means that if x is greater than y and a is less than b, then I want to do something. The and the or operators provide the same functionality as in other programming languages to combine two logical checks and take the final answer as one logical check. And we'll see the example in a minute. The not operator just is to convert true to false and false to true. So let's look at logical operators. And in this example, what we're doing is that we have our scored percentage and we have our passing percentage for the exam, which is defined. And there's one core exam and one secondary exam, which is present. Now, we want to print the fact that whether I passed or I failed. And at the same point in time, the answer is going to depend upon whether I took a core exam or I took one of the secondary or the optional courses that I can do as part of my curriculum. So let's start with the conditional checks that we're going to introduce. And I press command / to remove the comments. My first check is that, okay, if it is a core exam and my score percentage is greater than passing percentage for the core exam, then I pass. Or if it is not a core exam and my scoring percentage is greater than equal to the passing percentage for the secondary exam, then also I pass. So instead of me writing 2 if conditions, I combine them into one. As you would see, I have used brackets to make code readability better for myself. Now, of course, I could have put them into 2 different conditions with if, else if, totally doable. Or I can just combine them into one bunch with and say that, okay, if this or this is true, then success. And the advantage here is that if I'm using the or condition or the logical and conditions is well, in their scenarios, I will not have to write the code here. I'm just printing one line of code, but in reality, I might have 10 lines of code which are present. I don't have to replicate that between if and else if. I will write one conditional statement and I will execute that portion of the code. Now, of course, I can change the core exam from false to true, saying that, okay, it is a core exam. My passing percentage was 60%, so definitely less than the core exam. So sorry, better luck next time. That's all that you need to know about logical operators for now. Again, we will be visiting these topics again and again as we're doing the conditional statements. Moving on, the next one is bitwise operators. And these operators, I have to say, are rarely used. And most programmers go doing their job happily without ever having to touch these operators. But these are the kinds of operators you generally use in hackathons or some challenge quizzes. So we're going to cover them still. Way they work is that they are binary operators. So which means is that they work on each and every bit. Now let's assume that P and Q, there are different values of binary. Of course, they can be 0 or 1 only. So let's look at what these operators do. I have the bitwise AND operator, the OR operator, the NOT operator. Of course, I have a few other operators which are listed here, and I'm showcasing them just so that you have context regarding the same. And for all subscribers, they will be able to download these PDFs directly from the comment section. So you will have access to it to try it on your own. But for now, I'm just going to focus primarily on AND, or NOT operators. So let's look at it. I have 2 zeros, and P and Q basically is trying to get the value in case both the values on both sides is same. So if both are 0, the AND operator is going to return 0. If both are 1, then the AND operator is going to return you back 1. But if one is 0 and the other is 1, that's false. And if one is 1, other is 0, that's also false. Okay, so that's also going to be not meeting the conditions, it's going to be 0. Now the OR operator is saying that both the values, either one of them has to be true. Okay, so it's saying that, okay, if both are 0, you are 0. If either one of is 1, that is 1. If both are 1, then it's 1. If one is 1, another is 0, that's also 1. The NOT operator actually works differently. It's saying that, well, one of these values or these values have to be different. So if both the values are same, then it's 0. If one of the values is different, then it is 1. That's how the exclusive OR, sorry, I kept saying the NOT operator, correction, it's exclusive OR. So the exclusive OR works in the scenario that, hey, the values have to be different. They cannot be same. So when both are ones, it's 0. But in the OR condition where I was checking that if one of them is 1, then I'm going to take it 1. That both ones were considered as 1. That's the main difference between the exclusive OR and the OR. While in the AND operator, both have to be true and that's why only both being 1 was 1, otherwise everyone else was 0. Now let's look at it with an example. We have the bitwise operators which are defined here. I'm going to uncomment these lines of code, and this is fun because the answer doesn't make logical sense all the time. So let's say x is 1 and y is 21, and I have shown you the binary values for each one of them. And of course, you can do the binary calculation yourself as well. First, we are going to apply the AND operator. So if we apply the AND operator on 2 and 21, I'm guessing you would not have expected the answer to be 0. And the reasoning is because it's an AND operator, so both have to be 1. And 1 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 0 and 0 is 0, 0 and 1 is 0, and all others are 0, so they are 0, so answer comes out to be 0. Now, let's look at the same thing with an OR operator. Now, if I was using an OR operator, then it means is one of them have to be true. So 1 and 0 is 1, 1 and 0 is 1, 0 and 1 is 1, 0 and 0 is 0, 0 and 1 is 1. So the answer comes out to be 23. Now with exclusive OR is saying that, well, in that scenario, both cannot be 1. Okay, only one of them can be true. So as a result, if I'm looking at it, here there's never a condition of both being ones. So the answer is same between OR and exclusive OR. Again, not an operator that you will use heavily inside your programming practices, but something to be just aware of. Moving on, let's look at assignment operators. Now, assignment operators are basically, as the name suggests, are used for assignment. So single equal to is an assignment operator. So let's go to assignment operators. I have the first line and I'm assigning the value 2 to step count. That's an assignment operator. The other assignment operators are basically increment by addition and assign, subtract and assign, multiply and assign, divide and assign, and of course the modulus operator and assignment. So let's look at the example for the same. I'm basically taking step count and I'm saying is add it to myself. I could have simply said something like plus equals 3 as well. So in that scenario, what it's boiling down to is step count equals step count plus 3. So that's hence answer 5. So these are basically very handy shortcut operators. I'm going to skip out the prints, but let's look at step count plus equals. Let's comment this one up so we can still have 2 minus equals 1. Okay, now I'm left with 1. Now moving on, I'm going to go forward and say starting with 2, I'm gonna multiply it with 5. So the answer is going to be 10, and that's expected. Same thing we can do with the division operator, and we can say, okay, starting with 2, I'm going to divide it with 2. Answer is going to be 1. 2 divided by 2 is 1. Pretty straightforward. Assignment operators is something that you use heavily inside Swift, as you would have used in other programming languages like C, C++, Java, a bit more heavily in Swift because we do not have the increment operator. Now, a quick note on the increment operators in C, C++, Java, you would probably have an operator like you would define it as int I, but let's say where I equal to 0, and then you go forward and say I++. And what we'll do is that at the end of the expression, we'll go forward and increment it by 1. So I will now be 1. And you would use that heavily inside some of the for loops, which are written differently in Swift, but you do not have the increment operator present in Swift. Moving on, we are going to move forward to range operators. Now, these are some which are not very common in other programming languages, so we are going to cover all possible examples of range operators. There are three different types of range operators. There is the closed range, which is denoted by 3 dots. There's a half open range, which starts with the 2 dots and then has like a less than sign to it. And there are one-sided range operator where there's a marking which indicates the beginning of a range, or there is starts with 3 dots and there's a number which indicates, or variable which indicates the ending of the range, and we'll loop that number of times. So let's look at the range operators. I'm gonna give an example of for loops. There's a separate section which covers conditional statements like if, else, for, switch statements, but I'm not really covering them here. So I'm gonna assume that you have a basic understanding of a for loop. So let's go forward and look at the range operators. So very simple. I have a counter, okay, and I have not defined a counter here, okay, but what the for loop is doing is that is basically going in and saying is that for the range which has been specified here, which is from 1 to 5, I'm going to go through and loop through that particular range and assign the value to the counter one at a time. So I am going through 1, 3 dots, 5. The counter is first going to be 1, as you can say, the same second, then 2, then 3, then 4, and then 5, and so on. So that is my range operator. The other variation which I have is the half range operator, and I'm going to comment this portion out so that it's not confusing. The half range operator, what it does is that it's doing the same thing as a range operator, but it's less than 5. So it's not going to go till 5, but it's going to stop one value before 5. Moving on, we do have our one-sided range operators, and let's look at them. So in the one-sided range operators, what's happening is that let's say I have an array of numbers and it starts from 0 goes to 9, and I'm now saying I want to go over the numbers inside the array, but I want to begin at array where the index is 8 and then go through till the end. So it's going to go forward and it's going to start at the array index element of 8, and which is 8, and is going to loop through twice because the two values inside it, 8 and 9, and be done with it. Next scenario, I'm actually doing it in reverse. Instead of starting with 8, I'm going to say that, okay, well, I want to stop when I reach the array index of 2. So it's going to start as 0, so it prints a 0, and then it goes to 1, and then goes to 2, and then, of course, it stops because my one-sided range operator is finished. Again, as you can see, it's very powerful because as in the example, we can actually not only use it for numbers, but we can use it for array indexes. And that's where most of its value actually lies. Moving on, we have some miscellaneous operators which have been documented here. There's unary, minus, unary, plus, and ternary operator. Now, ternary operator is something of interest, so I'm going to cover that next. Let's look at an example where I am just simply trying to figure out whether learning a particular programming language is cool or not. And of course, I've initialized the variable as true in the beginning, and then I'm going there, simple conditional check to say that if it is cool, then just print, yes, learning this particular language is cool. Otherwise, print, well, this is not exactly what I thought so. So move on. Now, with an if-else condition, you have to write few lines of code. I went forward and actually wrote around 6 lines of code to actually do this piece, write this functionality saying Swift development is cool. Now let's look how you would have done that with the ternary operator. With a ternary operator, of course, you need a variable. So variable is there, but rest of the stuff you can do with a single line. So the way it works is that you have a expression which is present on the left of the question mark. The expression must evaluate to either true or false. That's a condition. You cannot have any other value coming out of this expression. So in my case, I'm just checking that whether being cool is true or false. So it's true in this case. So the expression evaluates true. True equals true is true. If it is true, the expression on the left-hand side of the question mark evaluates to true, then the first block of code on the right-hand side gets executed, which is if true, then execute this block of code. Otherwise, if the expression on the left-hand side evaluates to false, then the second block after the colon gets executed, and which is okay, sys development is not what I thought. In our scenario, true equals true, so we print sys development is cool. If I change it to false, then of course the expression on the left-hand side is not going to evaluate to true, so we're going to skip over this block of code and we're going to execute the second block of code, which is going to say, okay, sys development is not what I intended it to be. And again, this can be very powerful because instead of writing these print statements, you could have written function calls. So you could be executing full function with multiple lines of code to come up to the same conclusion. That said and done, there's one last topic which we must touch upon: operator precedence. And this is, well, what if I start writing some real complex arithmetic operations? And of course, no, it's not true only for arithmetic operations, but it could be true for anything else. Which is like, okay, I'm going to go forward and write as, okay, 3 plus 4 into divided by 2 into 7 and modulus 6. Okay, what's the answer which we are expecting out of this? Pretty complicated, right? And of course, it's complaining because I forgot to put the codes. So let me put the codes in here. It is complicated, and the answer probably is not going to be what you expected the answer to be. And the reasoning is that you need to be very familiar with how the operator precedence works. It's not that everything is getting evaluated always left to right or right to left. There is different operators are being evaluated in a different order, as you can see. Some are being going left to right, some are going right to left. So you need the operator precedence to be helpful. Now, from code readability perspective, I do recommend using these brackets. Now, we did use these brackets, if you remember. When we use logical operators, we did use these brackets to make our code more readable and say that where the logical blocks of the code exist between the or and the and operator. So there is no confusion between the usage of the or and the and operators itself. Um, so this is a slide deck. I'm not going to go over each and every operator and speak the same thing which is written on this slide, but keep this slide handy if you're new to operator precedence so that you can refer to it when the results are unexpected. But again, as I said in the beginning, I recommend using the brackets to make sure the code is as readable as possible. That concludes our discussion on Swift operators. Thank you for listening.